The permanent magnet. So the large dark circular base at the bottom is our permanent magnet. Next is the voice coil. As you can see in this figure as well, the copper colored wire wrapped around a cylinder in the center. Okay, that is our voice coil. Are you getting my point?
Yeah.
The copper colored wire wrapped around a cylinder in the center. And the third one is the AC signal. Okay, the third one is the AC signal.
Okay.
Where is it? The AC signal. So it is indicated by the yellow zigzag line. Okay, this yellow zigzag line. All right.
Okay.
Yellow zigzag line on the left, representing the alternating current. Okay, that means AC signal, right? Alternating current that is flowing into the coil. Okay,
Yeah.
so we discussed the diagram, right? What's going on here?
Yeah.
The core components. Now let's discuss how it works. Okay, basically
Okay.
electromagnetism, right? That is what we are right now discussing. Okay,
Okay.
how it works. Electromagnetism. All right. So first of all, electric current. Okay, so the functionality relies on Lorentz force. Okay, so
Okay.
let's discuss this step by step process. Okay, do you know what is a Lorentz force? Lorentz force is given by Q in the bracket E plus V cross B. Okay, this is the formula for Lorentz force. Okay, it might not be in your syllabus. Okay, but just
Okay.
for your information, this is the formula. Here E represents electric field, B represents magnetic field, and V is the velocity. Okay,
Yeah.
as you can write it this way as well. QVB represents magnetic force while Q times E represents electric force. So let's discuss electric current. So here in this circuit, in this diagram, an electrical audio signal flows through the voice coil. Okay, that is our
Yeah.
electric current. We represent electric current with this symbol I. Okay, here it's an AC signal. Okay, or you can say alternating current. Okay,
Okay.
now magnetic field interaction. Let's discuss magnetic field interaction. So as the current flows through the coil, it creates a temporary magnetic field. Okay, this
Yeah.
field interacts with the permanent magnet's fixed magnetic field. Okay,
Yeah.
as you can see here, this is our, yeah, this is our permanent magnet, right?
Yeah.
This black one. Now here, this is our AC signal, right?
Yeah.
Yes or no? So it creates a magnetic field. Okay, that interacts with this permanent magnet. Are you getting my point?
Yeah.
All right. So as the current flows through the coil, it creates a temporary magnetic field. Let's say this is our electrical wire, okay, and current flows in it. And if the current flows through the wire or a conductor, it creates a magnetic field around it. Okay, this is the magnetic field. All right. So it creates a
Yeah.
temporary magnetic field, and this field interacts with the magnet's fixed magnetic field. Okay, This black one is our fixed magnet, right? And a
Yeah.
magnet is having it's a magnetic field, right? This is our magnet, let's say. So it has its magnetic field. So this magnetic field, this current's magnetic field actually interacts with this one, okay? This permanent magnet's magnetic field. That is what going on here, okay? That's why it is called electromagnetic interaction, okay?
Okay.
Here, magnetic field produced by electric current interferes or interacts with the field of permanent magnet. Alright. Now let's talk about movement. Okay, as you can see in our Lorentz force formula, there was this term V, right? V represents velocity. Okay, velocity
Yeah.
means movement, right? So
Yeah.
let's talk about the movement. Okay, so
Yeah.
because the AC signal constantly changes the direction, that's why it is called alternating current. Okay, it alters, so it constantly changes the direction. Okay, so the magnetic forces rapidly alternate between attraction and repulsion. This causes the coil to move back and forth, okay, very
Yeah.
quickly. If coil moves back and forth very quickly, what do you think what will happen? Sound waves, right?
Yeah.
This coil is typically attached to a cone, the diaphragm basically. As the coil vibrates, the cone pushes the surrounding air, creating the pressure waves that our ears perceives as a sound. Are you getting my point?
Yeah.
So that is how a speaker works. Okay, it's a very simple device. Yes or no? So let me write it.
Yeah.